Hey guys, yesterday or Wednesday, we watched an ed puzzle that was all about long division. That was intended to be a reminder of a skill that you learned in elementary school because you learned how to do long division in elementary school. Well, today we're going to use that knowledge of long division and we're going to talk about, okay, what happens if we throw in decimals? Okay, how does that change our long division? As we've been studying with our decimals, we know that it's not always going to be nice and neat round numbers that we have to deal with. As you work through this video today, you are going to be solving some problems that involve long division where you get a decimal in your quotient. And we'll talk about what a quotient is in just a second. So today you're going to be using long division to find out what a quotient looks like when it is a whole number. A quotient is simply the answer to a division problem. So we're going to look at what happens when the answer to my division problem is a whole number, and then when it's not a whole number, and what you can do. Lastly, just because we're in decimals, you're going to be looking at where does my decimal point go in my answer. What I would like for you to do right now, I want you to look at these three criteria. How well do you know long division? Do you know what to do when you have a decimal point in your quotient? I want you to stop right now, and I want you to rate your understanding from a 1 to a 4. A 1 would mean I have no idea. I don't remember long division from elementary. I have no idea. A 4 would mean I'm an expert. I can not only do long division in my sleep, but I can definitely teach other people how to do long division. Rate yourself from 1 to 4 now, and give me at least a couple of words or a full sentence to explain why. In this situation, in the math that you see on your screen, Lynn is doing a long division problem. She is dividing 657 by 3. And she's walking through those steps that go with long division. A lot of times your elementary teachers may have given you a trick to kind of help you remember what the next step is in long division. Okay, we divide first. That's what's happening over here. Is she is saying, okay, 6 divided by 3 is 2. Next step, she's multiplying. There is that step. Okay, 2 times 3 is 6. So she's going to write that there. Next step is subtraction. 6 minus 6 is 0. Fourth step is bring down. She brought down the next place value, which in this case happened to be a 5. And then we're going to repeat. That's what that R means, repeat. So we're going back up. We're going to now look at how many times does 3 go into 5. Well, as she continues on over here, 3 goes into 5 one time. Start the process over. 1 times 3 is 3. Subtract, we get a 2. We're going to bring down this next place value right over here. So we're bringing down the 7. So now we're looking at 3 into 27, or 27 divided by 3. Well, 27 divided by 3 is 9, because 9 times 3 is 27, and we end up with 0. There are no other numbers up here for us to bring down. So because we end in a 0, that means there is no remainder. And our quotient, this answer, is a whole number. Now you're going to get a little bit of practice. You're still going to use long division. So I'm going to write our steps over here. So first you're going to divide, then you're going to multiply, you're going to subtract, you're going to bring down, and you're going to repeat. Your teacher in elementary may have had you remember this as dad, mom, sister, brother, rover. Okay, but you're going to do that. I'm going to set up the problem for you. 846 divided by 3. Notice the first number, this 846, is what goes inside my division bracket because that is what is being divided. The 3 that comes after it goes on the outside of my division bracket because that's what I'm dividing by. Let me get you started, and then I'm going to let you finish. I know that 8 divided by 3 is 2 because there are 2 3's in the number 8. There are not 3 though because that would be 9. So there are 2 3's that go into 8. Now I'm going to multiply. 2 times 3 is 6. I'm going to subtract. I end up with 2. I'm going to bring down my next place value, which is 4. And I'm going to repeat the process. You take it from here and solve the rest of this problem. Let's try on another problem. Again, my first number goes on the inside of my division bracket. So 1,816 divided by 4. Again, my steps, I'm going to divide, I'm going to multiply, I'm going to subtract, I'm going to bring down the next place value, and I'm going to repeat until I have no more place values to bring down. 4 goes into 18 4 times. 4 times 4 is 16. I subtract, I end up with 2. I bring down the next place value, and I repeat. You take it from here. As you can see from the work I just did, my quotient is 454. And I have 0 as my remainder, which means my quotient for this problem is a whole number. Check that against the work that you did. Well, what if I am using long division and I actually get a remainder? So I don't just end up with 0, but I end up with something else. What happens then? Let's look at this example. Lynn, again, is setting up her long division, 62 divided by 5. And she's walking through the steps of long division. So she's dividing. 6 divided by 5 is 1. Then she's multiplying. 1 times 5 is 5. Then she's subtracting. 6 minus 5 is 1. She's bringing down the next place value. So she brought this 2 down. And now she's repeating the process. 5 goes into 12 2 times. She reflects that over here. 2 times 5 is 10. Subtracting it means that you end up with 2. Okay, so the remainder is 2 because there are no other numbers to bring down. Always before in elementary school, you simply would just say like remainder 2. Even in the pixel art that we did Wednesday and Thursday, there were remainders and you could just put R2 and leave it at that. Unfortunately, you're now in middle school and we can no longer use remainders. So instead of just putting our 2, we have to figure out what that 2 actually represents. And what that 2 actually represents is I have 2 out of 5, because 5 is my divisor. I have to figure out, okay, what is 2/5? I have 12 and 2/5, but what does that mean in terms of a decimal? Here's what you're going to do. She put a decimal in here and brought down a 0. All whole numbers have a decimal point at the end and an infinite number of zeros behind it. That means as long as I put that decimal point in there, I can add as many zeros behind it as I want. But I have to put this decimal point in there, because if I don't, I've changed the value of the number. I've changed it from 62 to 620 or 6,200. But as long as I have that decimal point in there, I can use as many zeros after it as I want. Well, now that I have another number to bring down, I'm going to bring down that 0, and I'm going to look and say, okay, how many times does 5 go into 20? Well, 5 goes into 20 4 times. 4 times 5 is 20. I subtract. I finally end up with 0. I don't need to worry about any other zeros to bring down. You'll also notice she put her decimal point in the exact same place in the quotient or the answer as it is on the dividend, which is this number on the inside. I put my decimal there so I could add a 0. It's in the exact same place value in my quotient. When you add that decimal and that 0, that means a decimal needs to go in the same place in your answer. You're just going to move it up. Let's let you practice. Okay. This one actually gives you the answer. Your job is to prove that that's the answer through math. Since 5 divided by 4, or 5/4, has an answer or a quotient of 1 and 25/100. You're going to do the long division to prove that that's actually right. So let's set up the problem. 5 goes inside my bracket. 4 goes on the outside. 4 goes into 5 once. 1 times 4 is 4. Subtract. I end up with 1. Now, with the steps of divide, multiply, subtract, bring down, repeat, with those steps, I don't have another number over here to bring down, which would be my next step. So because there's not one there, I need to put one there. But I can't just add like a 0, because that means I've changed from 5 to 50, and I've changed the value. So instead, I'm going to put a little decimal there, because now it's still 5. And because I put a decimal there, that means I'm going to put a decimal there in my answer. I just move it straight up. Now that I have another number to bring down, I'm going to bring that down. 4 goes into 10 twice. 4 times 2 is 8. Subtract. I end up with 2. Ooh, I'm still not at 0. Means I still need to have another number to bring down. Now, I've already put my decimal there, so I don't need to put another decimal. But remember, I have as many zeros after this decimal as I want. So I can add more and more and more just so that I have another digit to bring down. I'm going to bring down my second 0. And now 4 goes into 20 5 times. 5 times 4 is 20. When I subtract them, oh, good, I am finally at 0. There is no remainder. So I've now just proven 5 divided by 4 is 1.25. Your turn. Prove that 1 divided by 8, or 1/8, is 0.125. Let's set it up. How many times does 8 go into 1? Well, 8 is bigger than 1. So 8 goes into 1 0 times. 0 times 8 is 0. I subtract. I still have 1. What do I do with that? Oh, yeah. I'm going to add a decimal so I have more numbers to bring down. Where I added that decimal, I'm going to put it in the exact same spot in my quotient. Now, how many times does 8 go into 10? 8 goes into 10 once. 1 times 8 is 8. Subtract. I end up with 2. Ooh, still not at 0. So I need to add another 0 and bring it down. 8 goes into 20 twice. 2 times 8 is 16. Subtract. I end up with 4. I'm going to bring down one last 0. 8 goes into 40 exactly 5 times, because 5 times 8 is 40. And when I subtract those, I end up with 0. So I'm done. Were you able to get that? Let's remind ourselves of some very important things regarding long division. Number 1, here are my steps for long division. I'm going to start by dividing. Like 8 divided by 4 is 2. Then I'm going to multiply. 2 times 4 is 8. I'm going to subtract them. 8 minus 8 is 0. And then I'm going to bring down the next place value. So I bring down that 6. So I essentially have a 0 there and 6. Because I don't have a remainder of 0 yet, that means I need to add a decimal and add a 0 so that I have a number to keep bringing down. 4 goes into 6 once. I subtract, I end up with 2. Bring down my 0 after my decimal point. You'll notice there's also a decimal point right there. 4 goes into 20 5 times. I now end up with 0. So following these steps is what's going to help you. And then remember, anytime you're left with a remainder, you're going to put in a decimal and as many zeros as you need until you get a remainder of 0. You're going to continue dividing. These were our success criteria that we looked at earlier. You rated yourself from a 1 to a 4. This time I want you to rate yourself again. Did your score go up? Do you understand even a little bit more? Or is it still the same and you need to seek more help? I'm not expecting your score to jump from a 1 to a 4 with just this lesson. But if you went from even a 1 to a 2, that is awesome. That's success. If you went from a 2 to a 3, awesome. You improved. If you went from a 3 to a 4, amazing. Our goal is simply to improve so we can get better. What you're going to do now is you're going to do some Check Your Understanding. Oh no, but not in Khan Academy. Our Check Your Understanding is in Delta Math. You are going to work on any homework that you have left from this week. If you didn't finish the Ed puzzle from Wednesday and Thursday, that was the intro to long division, you need to go finish that. Make the most of the rest of your class period so you give yourself the least amount of homework. Don't forget, if you are leaving this lesson feeling like you still don't understand long division, our math help sessions on Tuesdays and Wednesdays are a great place to come and get some help.